Okay.
Oh, right. Yeah.
Now, I posed a question to you, and I wonder if you had some time to think there, or were too busy getting salesmen. It's a verb, if you didn't know. I said there's an asymptote through here. My question is, how do you know? Or how can you tell? Remember, I'm trying to think about this in a visual sort of way, right? How would you argue for the asymptote? What is an asymptote? Could you define an asymptote for me?
A line.
Okay, that's a good start. That's a good start.
Can't be crossed.
A line that can't be crossed. Can we go any more than that? Let's just asymptotes in general.
Okay,
Equation
approaches the line.
Okay, good. So let's take this all together, right? A line that can't be crossed unless you're a horizontal oblique asymptote. There's my disclaimer bit. Because the reason why we can't cross it is because we're approaching it. We're approaching it endlessly, at least at a particular place. Okay. Now, how do I know that we're going to approach this line, y equals x? We're going to approach it. How do I know? Yeah.
Because the graph of y equals 2 on x is approaching
Good. Okay, did you catch that? Did you catch it? Let's try that again. Okay. Remember how I argued, or why I argued, that we were going to be close to this line over here. I got my ruler out, right? And I said, well, look, it's going to be the bottom line plus a little bit. And that little bit specifically was this distance here, right? That distance. Now, the important thing for you to get is that this distance is shrinking, right? Because there's an asymptote here, right? It's shrinking, it's going to shrink forever. That means this distance over here will also shrink and shrink forever, okay? So your asymptote up here implies an asymptote down there. Does that make sense? Okay, so visually that's a really important idea to get. All right, now, I said there's another asymptote here in the middle. But it's there for a different reason, sort of. Okay? How do you know there's an asymptote there? This is a vertical asymptote, right? So vertical asymptotes come from domain issues, right? They're where the graph can't exist. You truly can't cross a vertical asymptote, right? So looking at this part of the function, because x equals 0 breaks that part, that means x equals 0 breaks the lot, which is a little more obvious when you look at the whole thing as one fraction. Okay? So, therefore, I know what's happening over there. Now, what happens on the right-hand side? Okay? I could keep on doing the same thing and using this argument of what's more significant, where's it going, that kind of thing. But you can do something a little sneakier than that, which is that you can look at these two component functions. This is why we spent so long on it at the beginning, right? And notice, these are not just any functions. They are special functions, right? And you can see that in the green graphs, right? They're special because they have particular kinds of symmetry, right? What kinds? They're odd, right? This one's odd, and so is this one, right? When you add two odd functions, right? You add two odd functions, you're going to get another odd function. You can almost see it happening, right? And now let me argue for it visually, right? Over here, close to this x equals 0 asymptote, right? This function's more significant, and I'm going to be up here plus a little bit, because I've got a little positive value here, right? So I'm going up like that. Okay? In exactly the same way, y equals x is still the oblique asymptote, and I'm going to be here plus a little bit, that distance again. Okay? And you get the idea. Okay? So that was it. Addition of ordinates. Okay? Now, like I said, you could have gotten that shape just by doing this. Okay? When we get to these other graphs, you need to know this process of, well, look at the graphs, what are they doing, how are they behaving? Okay? Alright, now, let's look at this, and I'm going to ask you to do one by yourself, but this time, I'm going to change the addition to a subtraction. Okay?